Okay, now we will start. Is it the screen is visible?
Yes, sir.
Okay. The next point of our syllabus is the compatible system of first order partial differential equation. Okay, that is compatible system of first order partial differential equation. Okay, now look at the definition. What is the definition of compatible system? The equations f is the function of x, y, z, and pq. Okay, which is equal to 0. So this is the first order partial differentiable equation. That is equation number 1. And g is the function of x, y, z, and also p and q. So this is the second one is first order partial differential equation. Okay, so these two are the first order partial differential equation are compatible. Are compatible. Compatibleचा अर्थ काय? सुसंगत. सुसंगतपणे म्हणजे दिसायला एकसारखेच असतात. त्यांचा सोल्युशन काय असतो तो? त्यांचा जो काही सोल्युशन इज तो कॉमन सोल्युशन आहे. ओके, आर compatible on domain D on domain D if first condition the Jacobian J, okay, Jacobian of Fg with respect to PQ is not equal to 0 on domain D. Okay, and the second condition, P is equal to phi is the function of x, y, z, and small q is the function of small q is equal to psi of x, y, z. Okay, obtained by solving 1 and 2. Okay, then such that dz is equal to phi of x, y, z dx plus psi of x, y, z dy is integrable. Okay, if these two conditions holds, then we see that we say that the two equation f and g, the first order partial differential equations, are compatible system. Okay, to give this equation number third, this two. Okay, what is the compatible solution? If f is the function of x, y, z, p, q is equal to 0 and g is the function of x, y, z, p, q, that is first order partial differential equation, are said to be compatible if the Jacobian of fg with respect to pq is not equal to 0 on the domain D. Okay, so D is the domain and p is equal to phi of xyz and q is equal to psi of xyz, obtaining the solving the equation 1 and 2. Now solving these two equations, we get the value of p and q in terms of xyz, such that the dz is equal to p dx plus q dy is integrable. If suppose this function, this differential equation is integrable, then we say that these two functions are compatible. Okay, now the note. This is not the solution. Now give the equation, this equation, the number is 4. Okay, now solution of equation 4. Solution of equation 4 is of the form f of x, y, z and c, which is equal to 0, where c is integration constant in equation 4. Okay, so C is the integration constant. So where C is integration constant. Hence, we say that we say that if equation 1 and 2, if equation 1 and 2 are compatible, then they have they have the one parameter family. This is not f of x y z c is one parameter family. Why? Because c is the only one constant present. Have the one parameter family of common solution. Okay, any doubt up to here?
No, sir.
Now the next theorem. The next point is theorem is there. Theorem. What is the theorem? The necessary and sufficient condition, a necessary and sufficient condition for the integrability for the integrability of dz is equal to, that is p of xyz, p of xyz dx plus or phi. Okay, this p is nothing but y, phi of xyz and psi of xyz into dy is, okay, the necessary and sufficient condition for the integrality of this function, this differential equation is the fg, curly square bracket fg is equal to, what is the value of this one? The Jacobian of fg with respect to xp plus p into Jacobian of fg with respect to zp plus Jacobian of fg with respect to yq plus q into Jacobian of fg is upon with respect to Jacobian of fg with respect to zq. The value of this one is 0. Okay, so this is the necessary and sufficient condition for this differential equation is integrable. Okay, now look at the proof of this theorem. We know that answer proof. We know that the equations first for f of x, y, z, p and q, which is equal to 0. So this is the equation number 1. This is given to us. And sec for this is g, is the function of x, y, z, p and q, which is equal to 0. So this is equation number 2. These are the two first order partial differential equation are given that compatible. Okay, integrable म्हणजे काय येते? हे दोन equations, the necessary and sufficient condition for the integrability of this one, phi of xyz dx plus psi of xyz dy. इंटिग्रेबल असेल तर हे प्रूव्ह करायचं इज इक्वल टू 0 आणि हे इक्वल टू 0 घेऊन काय प्रूव्ह करायचंय? dz is equal to phi of xyz dx plus psi of xyz dy. Okay, now are compatible on domain D, on domain D. Okay, such that the first condition Jacobian of fg, that is Jacobian j is equal to Jacobian J is equal to Jacobian of Fg with respect to PQ is not equal to 0 on domain D. So this is the definition of compatible system. And the second one is P is equal to phi of x, y, z and Q is equal to psi of x, y, z obtained by solving 1 and 2. By solving this equation, two equations, we get the value of P and Q. And dz is equal to phi of x, y, z into dx plus psi of x, y, z into dy. This is equation number third. And this equation is integrable. Okay. So equation 3. Therefore, equation 3 can be written as phi of x, y, z dx plus psi of x, y, z dy minus dz, which is equal to 0. Okay, but we know that this is the Pfaffian differential equation is integrable when if and only if x bar into curl x bar is equal to 0. Okay, we know that this is the Pfaffian differential equation. Pfaffian differential equation is integrable if and only if x bar into curl x bar is equal to 0. Okay, where what is the value of x bar? Where here x bar is equal to phi of xyz, psi of xyz and minus 1. Now what is the value of curl of x bar? Is equal to, how to find the curve? Determinant of I, j and k. This is dou by dou x, dou by dou y, second row, and this is dou by dou z. And this one is phi, this one is psi, and this is minus 1. Now solve this one. I into dou by dou y minus 1. It's what? 0 minus dou by dou z of psi. It is psi z. Okay. Minus j into dou by dou x of minus 1 is 0. Okay. Dou by dou z of phi is phi z. Okay. Plus k into dou by dou x of psi. This is psi x minus dou y by of what? Phi. So this is phi y. Okay. Any doubt up to here? Which is equal to this curve of x bar is equal to minus yz. This one is plus phi z. This minus minus get plus phi z and psi x minus phi y. Any doubt up to here? Now consider x bar into curl x bar, which is equal to, what is x bar? Phi, psi and minus 1 into, what is curl x bar? Minus psi z, phi z into, and psi x minus phi y. Okay, now dot product of these two one, minus phi psi z plus this into this psi phi z, okay, and this one minus of psi x plus phi y, okay, which is equal to 0. If x bar into curl bar x bar is 0, then it is integrable, na? So this x bar into curl x bar is equal to minus phi psi z plus psi phi z minus psi x plus phi y is equal to 0. Okay, so this implies that minus psi minus phi psi z plus psi phi z minus psi x plus phi y is equal to 0. This implies that psi x, okay, take this one towards the right side, plus phi psi z, okay, which is equal to, this one is phi y plus psi phi z, okay. From x bar into curl x bar, we get this equation and give this equation as equation number 4. Okay, any doubt up to here?
No, sir.
Okay, now substituting phi and psi for p and q in equation 1, we get, okay, now substituting this value in equation 1. Now, what is the equation? This one is what? H value काय तुमची pdx. Pdx means what? Phi of xyz. And this is q dy. So this is psi of xyz. Now this putting the values in equation number 1. So here we get small f is the function of x, y, z and phi and psi, which is equal to 0. So give it an equation number 5. Now differentiate with respect to x and z, we get dou f. F is the function of x. So this is dou f by dou x. Now similarly, dou f is the function of now phi, and phi is the function of z, plus dou f is the function of psi. Okay, and psi is the function of z, which is equal to 0. That is fx plus f phi into this one is so here, sorry, f is the with respect to x करतो ना आपण ते x येणार. Phi is the function of x. Sorry, this is phi x plus f psi into psi x is equal to 0. Give it as an equation number 6. Okay, now similarly for differentiate with respect to z, we get similarly differentiating with respect to z, we get this fz plus f is the function of phi. Phi is nothing but what? P, na? Instead of phi, we can write p on. Okay. Instead of phi, we can write p directly. P लिहू शकतो आपण, because p is nothing but what? Psi, and q is nothing but psi. Okay. So fp into phi z plus fq into psi z, which is equal to 0, differentiating with respect to z. Now this is equation number 7. Okay, any doubt up to here? काही डाउट असतील तर विचारा. कोणती स्टेप कळाली नाही?
No, sir.
Okay, now multiplying equation 7, this equation by phi. and and adding to equation 6, adding to equation 6 we get equation 7 ला कशाने मल्टिप्लाय करायचं, find, and this equation adding into equation 6. So here we get fx plus y into fz, okay, plus fp, taking common fp common here, we get in the bracket phi x plus phi into phi z, okay, plus fq into psi x plus phi into psi z, which is equal to 0. This is equation number 8. Okay. Similarly, by doing the process, whole process for the function g of xyz pq, okay, we may deduce from equation number 2. What is equation number 2? G of xyz pq. We get similarly for g function gx plus pi gz plus, now here instead of f we get gp into pi x plus pi pi z plus gq into this, this is psi x plus pi psi z, which is equal to 0, and give it as an equation number 9. Okay. Now multiplying equation 8 by gp, this equation by gp, and fp to this equation. Okay, now multiplying equation 8 by gp and equation 9 by fp and subtracting and subtract, we get, okay, what we get, look at here, fx in the bracket fx into gp minus fp into gx, okay, plus phi into याला काय नाही मेजरमेंट मल्टिप्लाय केलंय जीपी ने आणि याला एफपी ने, सो fx minus fx gp minus fp gx, ओके, एका ब्रॅकेट मध्ये घेतलं into in plus phi into bracket fz gp minus gz fp, okay, plus in the first bracket phi x plus phi phi z into bracket fp into gp minus gp into fp, okay, this term get cancelled, okay, plus another bracket psi x plus psi phi into psi z into bracket fp gp minus gq fp fq, sorry, fq gp into gq fp is equal to 0. Okay, सॉल्व केल्यानंतर काय होईल, सबट्रॅक्ट केल्यानंतर हे इक्वेशन मिळेल आपल्याला. But what is the value of this one is fpgp, fpgp is get 0. Okay, now which implies this is the Jacobian of fg with respect to x and p plus this psi into, this is the Jacobian of fg with respect to z p plus This term get cancelled, 0. Okay, which is equal to हे काय होईल, तिकडे गेल्यानंतर काय होईल, मायनस होईल. हा टर्म तुमचा 0 झाला. 0 इंटू मल्टिप्लाय 0 काय होणार, हा टर्म 0 0 होणार. मायनस साइन psi x plus phi into psi z into this is Jacobian of f g with respect to p q. Okay, any doubt up to here? Now which is equal to, which implies the value of this one is psi x plus phi psi z is equal to minus, now say this is the j term, okay, minus 1 upon j into the bracket of Jacobian of fg with respect to xp plus phi into Jacobian of fg with respect to zp. Okay, any doubt? This is equation number 10. Okay, where j is equal to Jacobian of fg with respect to pq, which is not equal to 0, hence we divide both sides. Okay, any doubt? This thing is given to us. Okay, now similarly differentiate equation 5 with respect to, now instead of x z we differentiate with respect to y and z. We obtain a similar analysis as above, and then we get, instead of here x and z, we get y and z. जिथे x आहे तिथे काय येईल, फक्त psi x च्या ठिकाणी psi y येईल. ओके, instead of here we get psi phi y plus psi dz is equal to minus 1 upon j into bracket Jacobian of fg with respect to yq plus psi into Jacobian of fg with respect to zq. This is equation number 11. Okay, now equating equation these two, 10 and 11. Why? Because here we get both are equal. From equation 4, these both are equal. Okay, hence we equate equation number 10 and 11. तुमचे लेफ्ट हँड साइड काय तिथे इक्वल आहे. These both are equal. Which one? From equation 4, this and this side are equal. Hence we can equate the right hand side of equation 10 and 11. Therefore, now equating equation 10 and 11. Why? Because since from equation number 4. Okay, since from equation 4 and replacing phi and psi by p and q, we get 1 upon j into what is the value of this one? Jacobian of fg with respect to xp plus p into Jacobian of fg with respect to zp, okay, which is equal to minus 1 upon j into Jacobian of fg with respect to yq plus q into bracket Jacobian of fg with respect to this zq. Okay, now taking this side toward the right side. Now 1 upon j get cancelled, which implies Jacobian of fg with respect to xp plus p into Jacobian of fg with respect to zq plus Jacobian of fg with respect to yq plus q into Jacobian of fg with respect to zq, which is equal to 0. Hence, this fg, what is the value of this one? Fg, square bracket fg is equal to 0. Hence the proof. Okay, any doubt up to here? And the note is there. Note, a solution of equation number 3 is of the form capital F of x, y, z and c is equal to 0, where c is an arbitrary constant. C is an arbitrary constant, okay, or arbitrary parameter. Hence, we say that if equation f is the function of x, y, z, p, q, that is first order partial differential equation, is equal to 0, and g of x, y, z, small p and small q, you see, that is first order partial differential equation is equal to 0, are compatible, then they have a one parameter family of common solution. Okay, so this is the proof of the theorem. Any doubt up to here? कोणाला डाऊट असतील तर विचारू शकता, जर नसेल तर आपण एक्झाम्पल घेऊया. ओके, एक्झाम्पल घेतल्यानंतर अजून क्लिअर होईल. Okay, now look at the example number 1. Show that the equation f, okay, that is equal to p square plus q square minus 1 is equal to 0, and g is equal to p square plus q square into x minus pz, which is equal to 0, are compatible. So to show that these two solutions are compatible, and find the one parameter family of solution. Find the one parameter family of common solution. Okay, now look at this. What is given to us? Given f of x, y, z and p and q, which is equal to What is the f? P square plus q square minus 1 is equal to 0. This is equation number 2. What is g of x, y, z, p, q? Is equal to p square plus q square into bracket x minus pz. Give it is equation number 2. Now let us, we have to verify that this, the condition of compatibility. Let us verify both the condition, both the conditions of compatibility. Okay, we have, now we have to prove that, we have to prove that claim number 1, Jacobian, that is J is equal to Jacobian of Fg with respect to PQ is not equal to 0. Okay, by the definition of compatibility, first condition this one is not equal to 0 पाहिजे तुमच्याकडे. Okay, hence consider Jacobian of Fg with respect to PQ. What is the value of this one? Dou F by dou P into dou G by dou Q minus dou G by, येईल ना, सॉल्व करते हैं डिटर्मिनेंट. कसं सॉल्व करना थे? What is first row? Dou F by dou P, dou F by dou G, dou Q, and this one is dou G by dou P, dou G by dou Q. Okay, so which is equal to dou F by dou P into dou G by dou Q minus dou F by dou Q into dou G by dou P. Okay, now what is the dou value of this one? Dou F by dou P is dou P, dou G by dou Q 2qx, 2qx minus dou G by dou Q. Now dou G by dou F by dou G, हे dou Q काय येणार? 2q and dou G by dou P, dou G by dou P 2px minus z. Okay, so this is 2px minus z. Now solve this one. काय येणार हे? 4
प्लस 2qz.
कुठे? सॉरी
सर ते आन्सर येणार सर.
हे ना,
येस सर.
हे pz बरोबर आहे की px मायनस z इंटू 2q. आन्सर सांगताय का तुम्ही शेवट?
हो सर.
ते सांगता हा मला सॉल्व तर करू द्या. 4pqx minus this is 4pqx minus minus plus 2qz which is equal to 2qz but which is not equal to 0 on D. Okay, where z is not equal to 0. Okay, excluding excluding what? YZ plane, sorry XY plane. XY plane मध्ये तुमचा z 0 नसतो. ओके, excluding XY plane मध्ये तुमचा काय हा फंक्शन काय नॉट इक्वल टू 0. Therefore condition 1 is verified. Now the second condition, claim 2, finding P and Q, finding P and Q from equation 1 and 2. From equation 1 and 2, and if dou z is equal to P dx plus Q dy, that is dou z is equal to P is nothing but what? Phi of xyz. Pi dx plus and Q is nothing but what? Psi of xyz dy. It's integrable. तर हे असेल तर काय असणार ते गिवन टू पार्शियल डिफरेंशियल इक्वेशन्स आर compatible system. Now from equation 1 we can write from equation 1, what is equation 1? P square plus Q square is equal to 1. Okay, now put equation 2, put in equation 2 this value 2. We have, what is equation 2? Look at it, P square plus Q square into x minus pz, and what is the value of P square plus Q square is 1. So here we get x minus pz. Okay, so here we get 1 into x minus pz is equal to 0, which implies P is equal to x divided by z. So this is equation number 3, and give this equation is star equation. Okay, now put, this is the value of P now. Now put value of P in star equation, this one. We have, what is P? P square is x square plus z square plus q square, which is equal to 1, which implies q square is equal to 1 minus x square upon z square, which is equal to q is equal to, which implies q is equal to z square minus x square upon z square. This is equation number 4. Now putting the value of P and Q in, putting the values of P and Q in dou z is equal to P dx plus Q dy. We get, so this is dou z. What is P? X upon z into dx plus, what is this one? This is square root of z square minus x square upon z into dy. So which implies z dz is equal to x dx plus square root of z square minus x square. This is dy. Okay, which implies, how to find the integration of this one? Z dz minus, now this is x dx upon square root of z square minus x square, which is equal to dy. हे कोणाचं डेरिव्हेटिव्ह आहे?
Sir, root x.
Root z square minus x square, na?
Yes,
So this
sir.
is the derivative of root, or only, wait a minute. So this is the root of, and this is the derivative of z square minus x square, which is equal to dy. Is it correct? I will have the derivative.
Sir, 2 येईल तिथं.
2 येईल नक्की.
Yes, yes, sir. Root x 1/2 root x आहे.
1 upon 2 root x 2z. बघूयात काय काय 1 upon z square x square. त्याचा डेरिव्हेटिव्ह काय येईल? 2z. याचा डेरिव्हेटिव्ह काय येईल? 2x ना. 2 2 कॉमन होईल की, कॅन्सल होईल
Yes,
की.
sir. Cancel.
Okay, now integrating on both sides, integrating, we get, which implies z square minus x square is equal to y plus c, where c is the integration constant, which implies,
Sir, square root of z square minus x square.
wait, square root of z square sorry minus x square, which is equal to y plus c. Now squaring on both sides, z square plus x square is equal to y plus c bracket square, sorry minus with the minus a, z square. Okay, so this is z square is equal to x square plus y plus c bracket square. Okay, now this is the required one parameter family of common solution, is the required one parameter family of common solution. Okay, any doubt?
No, sir.
Solve this example. Example number 2. Show that the equation take us minute. Common solution. Now, question number 2. Show that the equation f is equal to xp minus yq minus x, which is equal to 0, and g is equal to x square p plus q minus xz, which is equal to 0, are compatible. These two are compatible, and find the one parameter family of common solution. Okay, now solve this one. Solve करा था. What is f? xp minus yq minus x is equal to 0. So this is equation number 1. Okay, what is g? G is equal to x square p plus q minus xz is equal to 0. This is equation number 2. Now first condition, Jacobian of fg. We have to verify that now. Let us verify both the conditions of compatibility. We have Jacobian of fg with respect to pq is not equal to 0. We have to check this one. Now consider Jacobian of fg with respect to pq. Now tell me the value of this one. Dou f by dou p and dou f by dou q. This is dou g by dou p. This is dou g by dou q. Tell me the value of this one. Is it correct? Dou f by dou p is x. Dou f by dou q is 1. Is it correct? Dou
Yes,
f,
sir.
hmm, x into 1 plus xy, but is not equal to 0 on whole diamond D, on D. Okay, now condition 1 is verified. Now what is the second condition? Claim number 2. Finding P and Q from 1 and 2, and dz is equal to p dx plus q dy. Okay, is integrable. We have to solve this. Is integrable. Okay, now from equation 1, we have xp minus yq minus x is equal to 0. Na? Now tell me what is the value of this one? This x into p minus 1 minus y into q is equal to 0. So what is the value of q? X into p minus 1 divided by y. Okay, this is the value of p. Now, therefore, the equation 2 becomes, now putting the value of q in equation 2, therefore, equation 2 becomes, what is equation 2? X square p plus x into p minus 1 upon y minus xz. Is it equation 2? Look at here. Putting the value of q here, minus xz, which is equal to 0. Okay, which implies x square yp plus x into p minus 1 minus xyz is equal to 0. Okay, now solve this and tell me the value of y. Tell me the value of p, which implies p is equal to, सॉल्व करते हैं ना, 1 plus yz upon 1 plus xy. Okay, so give it is an equation number 3. Okay, now from 1, what is equation 1? Xp minus yq minus x is equal to 0, which implies xp is equal to yq plus x. Therefore, p is equal to yq plus x upon x. Now putting the value of p here, we get, what is the p? Wait a minute. So this is p is equal to yq plus x upon x. Now equation 2 becomes, now putting this value, therefore, this is the value of p in terms of q. Now putting this value equation, therefore equation 2 becomes, आपल्याला p आणि q ची व्हॅल्यू काढायची in terms of x y z. Okay, now equation 2 becomes x square into p, तुमचं equation 2 आहे ना, plus q minus xz, which is equal to 0. So this is x square, value of p is yq plus x upon x plus, this is q as it is, this is xz is equal to 0. Now solving this, we get x get cancelled. So here you get xy cube plus काय येईल x cube sorry xy cube into x square plus q minus xz is equal to 0. Okay, which implies q taking common xy plus 1 plus x square minus xz is equal to 0, which implies q into 1 plus xy, taking x common, 1 minus x minus z. Okay, is equal to 0, which implies q into 1 plus xy, which is equal to, this is x into z minus x now. Okay, which implies q is equal to x into bracket x z minus x upon 1 plus xy. So this is the value of q. Okay, any doubt up to here? Solve करत जायचं आपल्याला फक्त. This is
So
equation number.
P must be in terms of x and z, and Q must also be in terms of x and z.
P आणि Q चे तुमचे फंक्शन्स x आणि z च्या x y z च्या फॉर्म मध्ये असायला पाहिजे. ओके, हे कशाला काढलं? बाय पुटिंग इक्वेशन 2 यूज करण्यासाठी काढले. ओके, काहीही करा, शेवटी तुमची व्हॅल्यू P आणि Q ची व्हॅल्यू हेच यायला पाहिजे. ओके,
Yes, sir.
तुमच्याकडे दोन इक्वेशन आहेत, दोन व्हेरिएबल आहेत, मग P आणि Q ची व्हॅल्यू मिळतील की नाही?
Yes, sir.
तेच काढायचे, फक्त प्रोसिजर करत जायचे तुम्हाला. ओके, अँड ऍट लास्ट now what is dz is equal to p dx plus q dy. Okay, now solve this one. Dz is equal to, what is p? 1 plus yz upon 1 plus xy plus, what is q? X into dx into dx plus, what is q here? X into z minus x upon 1 plus xy into dy, which is equal to, it is 1 plus xy into dy is equal to 1 plus yz into dx plus x into z minus x into dy. सॉल्व कर चले घरी.
Sir, the dz है 1 plus xy into
सॉरी,
dz.
dz. हे सॉल्व करता येईल, इंटिग्रेशन करता येईल. वेट सांगे कसं सॉल्व करतो. dz plus x into y dz is equal to dx plus y into z dx plus पुढे xz into dy minus x square into dy. Now add and subtract. Right? xy into dx in left hand side of equation, above equation. Okay, of above equation. So here we get, which implies so this is dz plus x into y dz. काय येईल? xy into add and subtract left hand side ला, which is equal to plus xy into dx minus xy into dx, which is equal to dx as it is plus yz dx plus xz dy minus x square dy. ओके, ह्याच्या पुढे सॉल्व करताल. शेवटी आन्सर हे. तो z माइनस dx अपॉन z माइनस x हे सॉल्व करा, सिम्प्लिफाय करा, which is equal to y dx plus x dy upon 1 plus xy. ओके, याचं इंटिग्रेशन काढलं तर काय येईल, log z मायनस x इज इक्वल टू log 1 plus xy plus log c. Okay, which implies log z minus x is equal to log c into 1 plus xy, which implies z minus x is equal to c into 1 plus xy. Okay, so which implies c is equal to z minus x upon 1 plus xy. So is the required one parameter solution. Okay, one parameter family of common solution is the required one parameter family of common solution. Okay, any doubt up to here? हे फक्त सिम्प्लिफाय करा, तुम्हाला मिळून जाईल dz minus dx upon z minus x is equal to y dx plus x dy upon x plus 1 plus xy. ओके, ठीक आहे. हा, काही डाउट्स आहेत का?
No, sir.
Okay, the remaining part we will see in the next lecture. Okay, wait a minute. Okay, you can leave now. Okay, thank you.
Thank you, sir.